Hello students, welcome to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now let's solve this problem from chapter 16, Hibbeler Dynamics. The problem says that determine the velocity and acceleration of the follower rod CD as a function of theta when the contact between the cam and the follower is along the straight region AB on the face of the cam. The cam rotates with a constant counterclockwise angular velocity omega. So we are required to determine the velocity and acceleration of this follower rod CD in terms of this angle theta when this cam is rotating in a counterclockwise direction with a constant angular velocity of omega. So we know that d theta by dt is theta dot, so that is equal to omega. So if omega is constant, then d square theta by dt square or theta double dot, this will be equals to 0 if the cam is rotating with a constant angular velocity. Now if we look into the geometry of this whole mechanism, here we have a right angle triangle, so we can draw this right angle triangle. So we are having a right angle triangle like this, and this is point O, which is the center of this cam. And here we have that point C where this CG rod is in contact, and here we have that point A. So here we have that point A, here we have that point C, and here we can see that theta here. So we have to find, we need to find the velocity and acceleration of this rod CD in terms of this theta. So in order to solve this problem, first of all we need to define a coordinate. We need to define a reference point from which we will measure the position of this point C. Since this cam will move in the counterclockwise direction, so this follower will move in the left. So what we can do is that we can define this O as a reference point, and from this reference point we can say that towards the right we will measure the position of this point C from this point O as a variable x. So this x will tell us the position of this point C from this reference point O. So now for this current condition, we can say that this OC, the length of this OC will be the distance of this point C from that point O, which is represented by x. So this means that in this triangle this OC length is x. So we can say that this is x, and this is given here in the diagram. This is given that this is 90 degree, this is 90 degree. So if this is 90 degree, then this is the hypotenuse, this is the base, and this is the perpendicular. So we can apply cos of theta. So cos of theta will be this base divided by hypotenuse. So the base is AO, and AO is the radius, right? This radius. So AO length is radius. So we can say that this is r divided by x, and from this equation we can say that x is equal to r divided by cos of theta, or we can say 1 divided by cos of theta is secant theta. So r secant theta. So we need to determine the velocity and acceleration. So the velocity is dx by dt, so we need to take the derivative of this equation with respect to time. So d by dt, dx by dt, this will be the velocity, and this will be d by dt r secant theta. And we can say that the velocity is r is constant, and the derivative of secant theta with respect to time will be secant theta tan theta and d theta by dt. So this is the velocity, and we can replace this d theta by dt by omega. So we can say that the velocity in terms of theta is r secant theta tan theta and into omega, or we can say that r omega secant theta tan theta. So velocity is r omega secant theta tan theta. Now in order to find the acceleration as a function of theta, we need to take one another derivative of this velocity. Is we know that acceleration is dv by dt, so we need to take the derivative of this whole equation with respect to time. So here we have three terms, which, and all these three terms are as a function, they are changing with respect to time, they are a function of time. So we need to apply the product rule on this and this. So we can write that this will be r, and let me write it as d by dt of secant theta tan theta d theta by dt, and further we can write that the acceleration will be equal to r, and then we can write that secant theta d by dt tan theta d theta by dt plus tan theta d theta by dt and the derivative of secant theta. So now the derivative of secant theta is, we know that secant theta tan theta, so I will write directly here that the derivative of this secant theta will be secant theta tan theta and again d theta by dt, so d theta by dt. And now here we can see, here we have these two terms which are a function of time as well. So again we need to apply the product rule now here. So this will be, acceleration will be equal to r, this will be secant theta, and now from this we can say that this will be tan theta and d theta by dt into d theta by dt. So this will become d square theta by dt square. So let me write it like this. This will be d square theta by dt square, and then we will write plus and d theta by dt, and then the derivative of tan theta. So the derivative of tan theta is secant square theta. So we can write that this is secant square theta, and then the derivative of theta will become d theta by dt. So d theta by dt, and plus we can combine all these terms. So this will become secant theta tan square theta. We can write this as secant square theta, secant theta tan square theta, and this will become d theta into d theta. So this will become d theta by dt whole square. This won't become d square theta by dt square. So this is d theta by dt whole square. We should know that this secant theta is only multiplied with this derivative, right? So this product rule. So we need to have a brackets here, right? So we need to have a bracket here, and then we need to have that bracket here, right? So now we need to simplify this. The acceleration is r, and this will be, if we multiply this inside, this will be secant theta tan theta secant theta tan theta d square theta by dt square, and this will become d theta by dt into d theta by dt. So this will become secant square theta, and this will become d theta by dt square. And similarly we will have, and here we need to multiply this secant theta as well, right? So this will be, this is secant theta into this, and then secant into this. So this will become secant cube theta, so secant to the power 3, and here we have plus secant theta tan square theta, and this is d theta by dt square. And now we know that d theta by dt is omega. So we can replace this by omega, and we can replace this by omega. So this is omega square and this is omega square. So let's represent this here. Let's write omega square. So this is omega square and this is omega square. And as we know that this omega is constant, so if d theta by dt is constant, d square theta by dt square will be equals to 0. So this means that this term is 0 since this is equals to 0. So this whole term will become 0. So let's remove this term. We are left with this term and this term. Now we can take omega square as common. So we can write that the acceleration will be r omega square into secant cube theta plus secant theta tan square theta. So this is the acceleration of that follower CD as a function of theta, and this is the velocity of this follower CD as a function of theta here. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy for the solution of such more problems from Hibbeler Dynamics, chapter 16.